Now, there's several things that you should be able to prove, just based on what you've seen. D of uv greater than or equal to 0. What are you going to do with that? Well, D of uv is magnitude of v minus u greater than or equal to 0 by the definitions we just gave. And what does this mean? This means that square root of v minus u dot v minus u is greater than or equal to 0. And what's v minus u? Well, let v equal v1, v2 through vn. U equal u1, u2 through un, etc. By etc., it means put this expression in for both of these v's, put this expression in for both of these u's. Then figure out what v minus u would be. What is v minus u? Well, clearly it's v1 minus u1, v2 minus u2 up through vn minus un. Then you dot those two things and prove two things you really have to prove. You have to prove that this is well defined, so what you get under here you better establish is positive, so you can take its square root. And once you've done that, you've got it. Now there's also the case where it's 0, so you might want to think about how that would occur, what would be necessary for this to actually come out 0, not just positive. But you're just replacing u and v with these ordered integrals, v1, v2 through vn, u1, u2 through un. Here, well, you just write out what this means. You know, it's the absolute value of u minus v, and this would be the absolute value of v minus u, and this would be the absolute value or the magnitude of u minus v. You write that out and prove that they come out the same. Again, you replace u and v with these two expressions. And you work it out as far as you can. If you don't see how it works out, well, bring it to me, I'll talk to you about it. Okay? You write this one out the same way. Here you've got a w, well, what are you going to do? We're going to use the same notation for u and v, but you're going to have, of course, have w equals w1 through wn. And I'm still writing an arrow over every vector, and of course that's wrong, as I pointed out. I mean, I'm writing an arrow over every component. And just because, we've been doing matrices and column vectors a lot, so my hand just kind of wants to do that. So be careful you don't. Okay? And you don't even really need the arrow over any of these. Okay, the ordered antipole satisfies it. And so forth. Okay? Now, these three are a little trickier. These four come out very, very easily if you see the right things. And the right things are pretty easy to see. And when you get here, there's some trickiness to it. But practice writing it out and asking yourself, well, why is this going to work? You might or might not see it. Okay, so that's really the trick. So I would recommend writing all these out using this notation. You can leave the arrow off, but be sure you also leave it off of every component, right? Just no arrows. You don't need arrows to do these.